We will start our today's session now. I have started the recording. Very good evening to all and all. So last class we were discussing about Playfair Cipher, right? And we have been discussing up to the rules and regulations for creating a keyword and phrase. I hope you people are clear with how this keyword, there is 5x5 table of cipher key is created. Anyone have any doubts in it? If you people are clear with it, can you raise your hands regarding Playfair ciphers keyword generation? I am yet to teach you the encryption part. Okay, thank you. Right. So there are now we come from the substitution rules. This is a substitution cipher, or we can able to call them as the encryption rules. Okay. So I'll directly jump into an example so that you people will get a clear picture. Okay. So now they're asking you to create a keyword or like a 5x5 table using a phrase called Playfair example. Okay. And they're asking you to keep that INJ as an interchangeable. That is, you have to keep INJ in a single box itself. That is a rule set here. So what they did in sense, they started filling the keyword phrase starting from first row. So Playfair PLAY. F A won't be coming in the fair because A already came here. So we would be omitting this A. Then I means I will be equal to J also in this case, right? So fair example EX A already came. M PLE is already available. Sorry, P is present here. L and E. So we can't able to use the entire letters in the word example. So with these two rows, we are able to fill the given phrase of Playfair example here. Now we are filling the rest of the elements as B, C, D, E and F already came here. Plus E is present here and F is present here. So E and F won't be coming here. Then G, H. Here J won't become because in a word called fair we are used this I, right? So if you are dropping I means then you will be dropping J also here. Right. Then K, L and M already came. Like this, we have already filled all the 5x5 keyword phrase. Right. Now they're asking you to encrypt this message called hide the gold in the 3 stump. Okay. The first step in Playfair cipher is nothing but you have to make your plain text to be ready for encryption. That is the first rule in the substitution rules. What is this making the plain text ready in the sense? You have to check is there any character or any letter which is repeated twice in a continuous manner. Like in this example, you can able to see there is a word called tree where the two characters E are repeated twice or in a continuous manner. So when there is a continuous repetition of letters, then you have to separate these two letters by inserting X between them. This X is called as a null value. Okay, you'll be inserting a character called X between these two elements of E. In this example, the two E's. Right. So since this Playfair cipher is a bigram, that is, we will be able to encrypt two characters at a time. Right. At a time. That's why it is going to encrypt a bigram or diagram types. So what I did in sense, I just grouped two characters, hide the THE, okay, gold GOLD. Okay. Then in the tree you can able to see TR. Here you can able to see they introduced an X between these two E's, right? So EX, ES, TUMP. This is the first rule people have to remember in the Playfair cipher. First you have to analyze the given plain text and you have to see if there is any characters repeated twice. Right. So I hope you people are clear with this example, this rule, right? If you are clear, kindly raise your hand. If you have any doubts, you can ask me now. So that I'll move into the encryption part. I hope I'm clear with my question also. If you people are clear with the concept of preparing the plain text, can you raise your hands? There's no reply. Thank you, Sandeep. Yeah. Now we'll start with the rest, encryption thing. Right, now the first one, we are taking the first diagram, that is HI. Now I'll be locating these two alphabet H and I in the 5 cross 5 table. Right. So in this I can able to see my H and I are present here, and keeping this H and I as a corner elements, I can able to form a rectangle shape here. Right. So the first thing you have to check in the sense what shape you are going to form. So the first thing is something where you're forming a rectangle shape. Next rule, I'm going to replace the plain text with the respective ciphertext values. How we are going to take in the sense, if a rectangle is formed with the corner elements of plain text, choose the elements in the same row in the opposite corners. For example, if H is the letter, the opposite corner in the row direction is B, and for I, the opposite direction, the row value is M. So H will be replaced with B and I will be replaced with M. This is the second rule. That is, if you are having a forming a rectangle shape, you have to choose the elements which are opposite corners, which are of the same rows. Okay. Now we went for the second element, hide HID, right? HI we just encrypted. Now we are going for the second pair, DE. So here we can able to see D and E are forming a shape of rectangle, but both are present in the same column. So we used to call them as a column shape. That is, you can able to see the elements D and E are present in the same column. So if you are finding these elements in the same column, what is the rule in the sense? You have to pick the elements which are just below the respective characters. So in this case, I have my first plain text D. So I will choose the character which is below this one as the replacement element, and E will be replaced with D. That's why your D is replaced with O and your E is replaced with D. Suppose if you have your plain text present here means, then you have to move to the next column and you'll be choosing this element here. That is here the wrap to the top if needed, which means if your element is present at the end of this column, go to the next column and replace it the first element here. This is a second rule here. That is, if your element is coming in the form of a column, you have to choose the elements which are just below each other. Now, next TH. Okay, so TH also forming a rectangle. So T will be replaced with the opposite corner called Z. H will be replaced with B. Right. Example, you can able to see you have elements of the plain text as E and G. E is present here and G is present here. So here the box, that is a rectangle, should be formed with this one. You'll be asking, sir, this is square. How are you saying this is a rectangle? Okay, it's a rectangle with equal sides. Okay. So what is the mistake usually people will do in the sense, if they have the E, they'll go with this M. G means they'll go with the B. No. The first you form the rectangle. Right. Then you have to choose the opposite corners in that particular rectangle alone. So E will be replaced with X and G will be replaced with D. Okay. So anyone have any doubts so far? If it is clear, kindly raise your hands. If you have any doubts, you can ask me regarding the first rule or second rule or third rule. Thank you, Arun. Thank you, Venkatashini. Thank you, please. Right. So again, O and L is also forming a rectangle. It goes on. Right. So we have encrypted this DINT and goes on. And if you come to a pair called E and H, that is where you got this tree. Okay, here comes your final rule. You people have to remember, because this E and H is present in a way that all are forming a row kind of shape. So it is present in a single row. So if the elements are present in a single row, then you have to pick the elements which are right hand side to the particular element. So in this case, we have E and H. So E is the next element to the right hand side is H, and for H, the next side element is M. So E will be replaced with H and H will be replaced with M. Suppose if you have M as your plain text means, then go to the next row and you choose this B as your replacement element for M. That is, if you wrap to left if needed. Left means you just go to the left hand side and go to the next row and you can replace the element. So these are the 4 rules. The first rule is nothing but prepare your plain text preparation. That is, you have to check whether 2 elements are repeated or not. Second rule, okay, if it is a rectangle, choose, if your plain text are present here, choose the corner elements as a ciphertext. The third rule is a column. As a column means choose the next elements below each other. And the fourth rule is row. You choose the next right hand side elements to each and every element of the plain text. Right? It's clear, guys. This is very simplest encryption technique. No math, nothing. Just a simple logic. This is worthy for 10 marks actually. It's like solving a puzzle, you can easily score 10 marks. Right. So anyone have any doubts in this one? If it is clear, raise your hands. If you have any doubts, you're most welcome to unmute and ask.
Sir, I have doubts.
Yeah, Venki.
So what if it doesn't have a pair? We left with only one word.
Okay, yeah, it's a beautiful. I mean, for example, you assume that if I am ending with stumps, means I'll be ending up with yes here. Means there also you have to introduce this yes. This yes will be introduced here. This was I was about to tell the next time. You ask the exact doubt. Suppose if you are not having a matching bigrams, you have to add the null wherever required at the end.
Okay. Sir.
Anyone have any doubts, guys? If it is clear, raise your hands so that we'll move on. Thank you, Arun. Right. So it goes on, and this is the ciphertext which has been formed for this plain text. Okay. So now I want you people to post answer in the chat box. Okay. This is the plain text. Simply hello. I just given you a single word, and I given the secret key this one. I want you people to tell me the final ciphertext. Okay, first rule, check whether you have to modify the plain text to be ready for the encryption. Next, you apply your all rest of the 3 rules and tell me the answer in the chat box. Hardly takes 2 minutes for this one. You can use the chat box to post your answers. If you face any difficulties or anything, kindly notify me so that I will help you. Anyone have any difficulties in this one?
Sir, ECQZBX.
Yes, yes. You just post it in the chat box so that everyone can know I think your answer is correct. Is this you're getting Arun? ECQ is a PS?
Yes, sir.
Okay, perfect. Thank you. Now we move on to next technique called field cipher. Okay, this is also a substitution technique. Okay, but this is a breakthrough technique in traditional cryptography. Why? In the sense, this is the first encryption technique coming under polygraphic substitution. What do you mean by this polygraphic substitution in the sense? If we see all the encryption techniques which we have discussed before, Playfair cipher, we can able to encrypt only single character at a time. Whereas if you take a Playfair cipher, you can able to encrypt two characters at a time, right? But in case of Hill cipher, you can able to encrypt more than 2 or 3 characters based upon your convenience. You can able to even encrypt 10 characters at a time. Okay, so this was introduced by Lester S. Hill in the period of 1929. Okay, so here he created an electromechanical device which can able to operate on more than 3 symbols at a time. That is, you can able to encrypt 3 symbols at a time. Okay. So here we should need some basic knowledge about matrices. So I'm not going to discuss anything about matrix here. I will, you people have to refresh yourself. Okay. So how this one works, we'll just see. So here you'll be using positional values of the English alphabet starting from A to Z. If I giving them the values from 0 to 25, right? So here if you want to encrypt each and every block of letters in sense like if you're going with 2 characters or 3 characters, this n will decide the size of the block. Okay, so this will be multiplied by a key, which is be a key is nothing but a matrix, which has the size of n cross n matrix, and the most important thing is nothing but the matrix should be an invertible matrix. Why they are specifying it should be an invertible in the sense because then only the inverse of that particular n cross n matrix can be used in the decryption process. So during encryption process, we'll be using n cross n matrix. Assume that you have a matrix called A, which will be used for encryption. Okay. Then you should know to create the A inverse, that is a inverse of the particular matrix will be used for decryption. So how to find the inverse of a matrix from the given matrix? You people should be already aware of it, and if not, just brush yourself. Okay. We'll see how this one works, and this is how you can able to define whether the particular matrix is invertible or not. You find the inverse, and if you multiply both of them, you'll be it should be ending up with an identity matrix. Right. So here we have taken a simple word called act, okay. And here they given you the key, which is of size 3 cross 3. So whenever your key size will decide how much character you can able to encrypt at a time. So here is a 3 cross 3 key, so I can able to take only 3 characters at a time. For example, if you act in the hall means you have to take 3 characters, then you have to fill up. Suppose if you are not having, for example, if I give you a word called apple and asking you to encrypt using a 3 cross 3, here first you'll take APP, then LE, then you have to add this X as a filling character, then you'll be performing the encryption. Okay, now you'll see this is the key they are given, and this is the plain text A, C, and T. The positional values of A are 0, C is 2, and T is 19. So I'll be getting a column matrix and following a column matrix or a vector as a 0, 2, and 19. Okay. Here, how the encryption is going to be done in the sense, I'm taking the key matrix here and I'm multiplying with the plain text matrix. This part you people have to be very careful in examination. If you interchange the multiplication process, that is plain text multiplied with key, or if you take if you're forming a 3 cross 3 matrix with the other thing and multiplying using calculators, your answer will go wrong. Always take column wise, perform the multiplication. You'll be ending up with big numbers like this. So we can't able to find the equivalent replacement in the lookup table here, that is from 0 to 25. So this entire matrix which we got will be undergoing a modulo operation with 26. So we'll be taking 67 and I found the mod 26, I'll be getting 15. 222 mod 26, I'll be getting 14. 319 mod 26 will be getting 7. Then you'll be finding the respective alphabets which have been positioned at 15th position, 14 and 7. So if you see here, in 15 I got P, in 14 I got O, right, and in 7th position I got this H. So it says ACT is replaced with POH, right. So this is the flow of Hill cipher, a basic encryption. Anyone have any doubt in this one?
So, can you tell us how you got the end modulo 26?
Yes, this part I was about to teach you. Like, I mean, you're asking how you took this module 22 mod 26
Yes,
as
sir.
model. Yeah. I hope everyone have calculators with you. Even if you don't have your scientific calculators, at least your mobile calculator will do. You will take the biggest number, 319. Okay. So I'll teach you, this is the simplest method. Okay. In examination, you can use this one. First step, what you do in the sense, 319 divided by 26. Can you people tell me the answer with the like 5 to 6 decimals? What is the answer you're getting? You can use chat bots or you can unmute and tell. 319 divided.
12.269230.
Yeah, you'll be getting
12 point
12.269
230.
220 and it goes up, right? Fine. Second step, what you do in the sense, remove this decimal value. That is, you take this entire answer. So if you are using calculator, you'll be getting this answer if in a scientific calculator minus 12. You'll be getting the answer to be 0.269230 and goes on. Right. Third step, take this answer, that is the decimal point 0.2 and goes on, multiply with this 26. Can you people tell me what is the answer you're getting here? Anyone? What is the answer you're getting?
6.83.
Okay, if you have reduced this decimal numbers, okay, you'll be getting 6.833. But if you use I mean your scientific calculator, you simply this one, and if you multiply with 26, you'll be exactly getting 7. Anyone using scientific calculators, you'll be getting exactly this one. Or if you get this 6.8 something, round it up to the nearest number, you'll be getting the exact answer. Yeah. So if you want to try with this one, you can try and let me know. 22 divided by 14, you'll be getting some decimal point and goes on. Then you can remove the decimal and multiply the digits which are after the decimal point. If you clear with this thing, you can raise your hand. Yes, sir. Yes, sir.
Shouldn't be divided by 26.
Oh,
Sir,
sorry. This is 26. Sorry. Sorry, sir.
yes, I got it.
So the simplest way you can, without even having a mod, button in your calculators, you can easily use your calculator to find this mod. Is it okay, Arun?
Yes, sir.
Okay. Whatever the bigger number you get, you can be able to calculate this mod easily. Right. Suppose in the examination, if you people provide you this is the encryption key and this is a cipher text, and we ask you to find the decryption means, then you people have to find the inverse of this matrix. This inverse will always lead to a larger numbers. Then you have to take modulo for that one. This is the inverse of this matrix, key matrix. And if you multiply this inverse matrix with your cipher text, you'll be getting a larger number. Again, you take a modulo, you'll be getting your plain text back. Right. Am I clear, guys,
Yes, sir.
regarding the cipher? Okay then. So anyone have any doubts or any clerical issues apart from Arun, other guys? If you are clear, kindly raise your hand. If you have any doubts, kindly unmute and ask. I think only like 4 to 5 people and myself alone learning cryptography, it seems. One day I'm going to delete all the downloaded videos. Let's see. In recorded videos. Now we move on to our next one called transposition cipher. Okay, so now we have completed all the substitution cipher techniques which we already discussed. I hope you can remember. We have discussed Caesar cipher, monoalphabetic, polyalphabetic, Playfair, and Hill. So now we have completed your substitution techniques. Now we are moving into transposition techniques.
So can you try a question for Hale cipher as well?
I mean, I can't get your question. What is it?
So can we try a question for Hale cipher as well?
Try means okay. You want to
Yes.
multiply and see.
Yes, sir. Sir,
You
if you
want
have any example question.
actually in this slide I don't have. Okay, in the next class shall I bring?
Yes, sir.
A simple multiplication, matrix multiplication. You want to go with it, right? That's your. I mean, with it's like a bigger sentence kind of thing.
Yes, sir.
Okay, okay. Next class I'll just bring it. Don't worry. Okay, now we move on to next one called transposition cipher. So here as a transposition cipher, which the unique part is something, but it does not substitute any symbol with another symbol. That is, your plain text characters will be present in the cipher text, but only condition is nothing but their locations will be changed. Okay. So simple transposition cipher which have been used in the history are generally keyless. There won't be any key. Only the technique will help me to jumble the given plain text. One of the simplest cipher is called a rail fence technique. Okay, what they will do in the sense, for example, you can able to see here the plain text is it's meet me at the park. This is a plain text. So what they will do in sense they will write the plain text characters in the type of rail fence, and at the end they will write the ciphertext as M E M A T and goes on like this. Then after K they will write E T E T H P. So here you can able to see meet me at the park. They have not replaced any character with any other character, but only they jumbled or they changed the position of this plain text. This is called a transposition cipher. This is one of the very basic cipher called rail fence technique. Okay. Then they went with other way of writing the plain text. That is, they will what will do since for example here they wrote the plain text in terms of rows. Meet me at the park, right? And the cipher text, what they did in sense, they took the column values and they wrote like this MMTA, you can able to see MMTA, then EHR, EHR, and so on. This is the other way of writing where you can able to change the position, right? So here we can able to see there will be a permutation of each and every character. For example, if you take the previous example itself, the first character is in first position, no issues. Okay. The second character, this is second character in plain text, which is present in the fifth position. Then third character here will be present in the ninth position here, and so on. Right, that is you can able to see first character is in first position, second character is 5, 9, fourth character is 13. Then after this part, you can able to see there will be a pattern of repetition after every 4. Okay, we see this. There is difference between these two or four numbers, and the difference between this one and the first character here is also 4. 5 plus 4 is 9, right? Sorry, this is one, I mean, difference here between this one and this one is 1, and between these two are 4. So once you get this 2, you can able to get the position of other values by simply pushing it to 4 characters. Then if you get 3, push it to 4 numbers. So this is one of the drawbacks how the attackers can able to easily find the transposition cipher. Right. So what I just said here is mentioned. So there will be pattern of permutation is available in the transposition cipher. So you have to design your transposition technique in such a way that they can't able to recognize the pattern of your change in position. So this is a basic prototype of a transposition cipher. Anyone have any doubt in this basic thing of transposition cipher? Next we move on to higher end techniques which came across. These are the basic, like how CC cipher was a basic for substitution technique. This rail fence technique and writing the column and row is the basics of transposition ciphers. If it is clear, raise your hands. If you have any doubts in this one, you can ask them. Okay. Thank you. Then came the keyed transposition cipher. Till now we just saw without any key. Then came a keyed transposition cipher not to make the entire cryptographic system to be more robust for attackers. They introduced a key. Okay. So what is this key? Means this key will tell me how the positions has to be changed. There won't be a pattern available in key transposition cipher. One of the basic techniques is this one. Here, for example, here the original message is enemy attacks tonight. Okay. And they said they will be going with a block type of encryption. They will be taking five characters in each block. And at last, we don't have 5 characters. So they introduced a null character called Z here. So in examination, you can use either Z or X, but you have to mention which is the null character in the answer sheet. What is the null character you are going to use? Okay. So here they filled with the Z here. So here the key is this part. This is the key, encryption key, which mentioned the key is 31452. So what they will do in sense, so I want everyone to listen to this very carefully, guys. This is the basic thing which will be used even to the present modern day cryptographic technique. Okay. So whenever a transposition cipher comes, the numbers and the position of numbers will determine the things. What do we mean by here? The position of this first box, this is the position is 1. These are positional values. Right? 1, 2, 3, 4, 5. And these are the input values which are written. So the numbers present inside this box denote the input values here, and the position where it is placed will tell me the output of the one. So the number 3 is placed in first position. So I will be taking this input from third value and I will be putting in the first position here. Right. And the second input is from the first value. So this is the first value and it will be placed in the output will be in the second position. So I take this one and I placed here, right? And the third input will be from the fourth value. The fourth value is here and it will be placed in the third position and so on. Right. If you go in the decryption process, simply they will take the, I mean, decryption means you have to go from bottom to top, right? So you can able to see if you are going with bottom to top approach, bottom to top, I'll be taking the first character here and it will be placed in third position. So first character will go with the third position. So obviously entire thing will be a reverse one. Here the thing which should be kept very secret is nothing but the key here. This key should be kept very secret. This is a basic keyed transposition cipher. So the values here, the value denotes the input, the position of the values denote the output here. Is it clear, guys? Anyone have any doubt in this one? It is clear, raise. I mean, you're not clear or you're clear?
So it's clear.
It's clear. Okay, okay. So how they have enhanced this one? Key transposition cipher. Instead of taking the values directly, they introduce the method of writing and reading in terms of column and row. So here they got the plain text here. They started writing row by row. You can able to see enemy. This is written row by row. Enemy attacks tonight. Right. Now they took the key. So what they did in sense, the 3 denotes the third column. So third column is taken here and it is placed in the first column. You can able to see third column is taken and is placed in first column, and first column is taken and placed in the second column, right? And fourth is taken and it is placed in third, and so on. So after they shuffled this column, they started reading it by column wise. They didn't read this way. They started reading this way. So it is again there is a change in position, right? So double encryption kind of thing is happening here. Okay, so they wrote it. I mean, they read it by this way, and they got the cipher text like this. So that we have a enough number of permutation applied here. Decryption wise, they first write it by column. Okay, then they decrypt. So while decrypting, for example, the fifth column will be pushed to second portion. So the fifth column is taken and it is pushed to second portion. Fourth column is taken and it is pushed to fifth portion. The fourth column is taken and is pushed to fifth portion. And at last, they started reading by row to get the plain text back. Right. If it is clear, raise your hands. Because if your people are clear with this one only, then you can able to understand the key generation process in transposition cipher. That's right. Okay. I stressed on this key generation process in sense. Here, this key will be used in encryption part. In decryption, he has to have this encryption key knowledge, then he have to perform this reverse thing, right? So what they did in sense, they want to use two different keys. Here you can able to see the, as I said in the initial discussion, there will be a same key will be used in the both encryption and decryption, or there will be two different keys, but the two different keys will be having some relationship between them, right? So here, how this is how the key which will be discussed in the previous slide. So 31452. So decryption key they used 25134. So how comes how this is possible? You see the previous example. This is 31452 is the key which I used. Okay. So if you find the reverse thing here, for example, the second thing is placed in the first position, right? So 2, and in the second position they found the fifth one, so 2 5 4. I mean, and then third one comes to 1 and goes on. We'll see how this key generation works. That's how they got this 2 5 1 3 4. So how this key generation can be done very easily. This is the process here. I want everyone to listen to this carefully also. So this is, for example, this is the encryption key you have 2631475. Okay, the first step, what I will do in sense, I will add the index value. Index value is nothing but your position values of these keys. So simply 1, 2, 3, 4, 5, 6, 7. Next step, I have swapped these two. You can able to see I have pushed whatever present in the yellow box to come out here. So you can able to see this is your step 1 and this is your step 2. So after swapping, your 1, 2, 3, 4, 5, 6, 7 went here, and this key value 2631475 came out. Right. Next, what I did is I went for the sorting, which is third step. Sorting in sense I'll be sorting these values. This 2631475. If I sort accordingly, I'll be moving the values inside the yellow box also. You can able to see here. Okay. So I have this value of 1. I push this value of 1 here. Automatically this 4 also came here. Now I place this 2 here in the exact position. This 1 came here. You can able to see here. Right. Like this I sorted the entire thing and I end up with yellow box also sorted. And this sorted value will be taken out as a decryption key. So this is how you can able to create your decryption key from the encryption key. You can both the keys will look different, but both the key have some relationship between them. This is the basic idea behind how we can able to use two different keys for encryption decryption with different values, but there is a relationship between these two values. Is it clear, guys? If it is clear, kindly raise your hands. Okay. Thank you, guys. Then they went for double transposition cipher. That is what they did in sense. We just saw an example, right? We have written by row permutation in the sense what we did with the key, this encryption key. Then we read by column. What they did in sense, they went with a double encryption to get a further jumbled version. This is how they increase the iterations. Thereby, they can able to make the system highly robust at the cost of they increase the computational cost, right? So here it is a computationally complex compared to single transposition cipher. They went for double transposition ciphers. Okay, so with this I will wrap up today's session. Okay, in tomorrow's class we move on to rota machines. Right. So anyone have any doubt in today's session? You can ask me now.